Okay, so for every one of these, the request is find the domains and ranges of the following functions. We'll go through these. I'll go through the entire batch in one big stretch here. So in many cases, working out domain and range is just a matter of knowing what the graph looks like. If you have a line like y equals 2x plus 3, that's a straight line. It extends forever in both directions, which means as far as the x is concerned, it goes forever to the right and left, meaning you can say the domain is xer. X is any element of the real numbers. And looking in the y direction, this goes up forever and down forever. So it's also covers every element of the reals in the y direction. There's no y value that this line won't reach if you follow it long enough. If you have root x squared plus 2, you can graph that, and it's got a shape that almost looks like an absolute value. It's got a tiny bit of curvature to it, but not a great deal. Drops and then rises again. It turns out x can be any real number here. You look at what's under the root and you think, could this ever be negative? And the answer in this case is no, because x squared is 0 or greater. Add 2 to it, and now you've got something that's 2 or greater. And so there's never any x values that can cause trouble with the square root. The domain for this is just x is any real number. For the range, well, there's no limit to how high this could get. X can go infinitely big. The smallest this radicand can ever become is 2, meaning the lowest that the y value could ever become is root 2. You could say y can be any real number, sorry. Y is always greater than or equal to root 2. Next, no roots in here, so nothing to worry about from that side, but we do have a division, and so we're worried about the denominator being 0, meaning x cannot be 2. If it were, we'd have 1 over 2 minus 2, which would be 1 over 0, which would be undefined. So we have to patch that and say x, don't be 2. As for the range, well, to find the range, you have to solve this thing for x. So if we multiply both sides by x minus 2, we get x minus 2y equals 1. Now divide both sides by y. X minus 2 equals 1 over y. Add 2. X equals 1 over y plus 2. And now we can look at this and say what values of y would make this impossible or undefined. Answer, if y is 0, we'd be in trouble. We'd get a division by 0, and so we must forbid that. Y, you are not allowed to be 0. For both of these, you could also put in xer, yer if you wanted. I normally do. I'm not doing it in this case because I'm a little tight on space. But if you say the domain is x is any real number except for 2, that would make perfect sense as well. Here, we have a radical, so right away we worry, what if 1 minus x squared were negative? That would be trouble. Can that happen? Yeah, it can happen if x is greater than 1 or if x is lower than negative 1. In either one of those cases, we'd get a negative radicand. So either one of these things would be bad. We can't allow either of them to occur. So we're going to say our x, actually I can't write it that way. I need to start with x has to stay between minus 1 and 1. As long as x is in that interval, this radicand will stay positive, or at least it'll be 0, and the square root will exist. If x gets any higher than 1 or any lower than minus 1, the radicand goes negative, our square root blows up. And if we look at y values now, essentially this radicand, the highest it can ever be is 1. The lowest we can allow it to be is 0. It can't go negative or the root blows up. So we're taking the square roots of numbers between 0 and 1. Those numbers are also going to be between 0 and 1. So our y is going to fall in the interval 0 to 1. 4x squared plus 1 is a parabola, which opens up, and its vertex is at 0, 1. So from that, you can pretty easily pick off the domain and range. There's x can be any value you want because any number can be squared and quadrupled and have 1 attached to it. That's no trouble. As far as y is concerned, the lowest value we could ever get out of this is 1. It's always 1 plus 4x squared can be anywhere from 0 up to arbitrarily big. So for our y, we're going to have y is 1 or greater. Absolute x minus 2 is a v-shape, like so, which has its vertex at 2, 0. Is there any x value we can't absolute value? No, not really. X can be anything. And for our y coordinates, well, an absolute value is always 0 or greater, so the lowest this can ever be is 0, and there's really no limit to how high it can become. So for the y, we're going to get y greater than or equal to 0. 1 over root x minus 1. Well, if we solve for this, sorry, we'll be solving it for x in a moment, but I take that back. First, we have to worry about the x values. First, x can't be 1, because if it is, we get 1 minus 1 is 0, and division by 0 is undefined. Also, if x minus 1 is negative, then the square root will malfunction, or it'll be undefined. So x minus 1 less than 0 would be bad, meaning x less than 1 would be bad. So x can't be 1 and x can't be less than 1 either. Basically, we need x to be higher than 1, or else this expression is not going to work. So for its domain, we have x must be greater than 1. 1 is no good because of the division by 0. Less than 1 is no good because we get the square root of a negative. Now, as far as y is concerned, I'm not sure we even need to solve this to see what's going to happen with y. Y is 1 divided by a guaranteed positive number. Right, the square root, this means the positive square root, so we can't get anything negative out of here. That means our y has to be greater than 0 all the time. It's always going to be a positive value. 1 divided by it, no matter how big this gets, it will never reach 0. Even if you have 1 over a trillion or 1 over a quadrillion, this never gets to 0. It just becomes very small and positive. So our y can be any positive value. 1 over x, well, we can't have division by 0, so we would have to say x is not allowed to be 0. For y, we have to get a positive value out of this, and so again we're going to get y has to be greater than 0. 1 over x can be negative, but not once you put an absolute value on it. So y can be any number. There's no minimum or maximum to it. It just can't be 0 or negative. 2x over x minus 1. I couldn't tell you exactly what this graph looks like without going to the calculator or doing a bunch of analysis that we'll show you in Unit 5. But for now, we'll see if we can get by without the graph. Certainly x can't be 1, because if it were, we'd get division by 0. So there's our domain. And for the range, this is one where we have to solve it for x. But how do we do that when there's x in 2 different places? That's a little annoying. Answer? Long division. Remember doing this? 2x divided by x minus 1. We don't need it very often, but we need it here. X goes into 2x twice. 2 times x is 2x. 2 times negative 1 is negative 2. Subtract and we get nothing. 0 minus negative 2 is 2. So this expression is equivalent to 2, that's our quotient, plus 2 over x minus 1. There we go. If you look at it this way, you can still see that x can't be 1. We knew that already. But now we can also look at what would happen, what y values are not allowed here. If we start with y equals 2 plus 2 over x minus 1, subtract 2 from each side. Multiply both sides by x minus 1. Divide both sides by y minus 2. and add 1. I'm just going to move that to the other side because I need the space. Okay, so what y values aren't allowed? Looks like there's only one. Y cannot be exactly 2. So that'll be our range. Y cannot be 2. You could see that coming just from this expression, really, because this says y is 2 plus some non-zero amount. 2 divided by a number can never be exactly 0, so this y is always going to be 2 plus something. You can never land exactly on 2, but you could land exactly on any other value. So from this, it is possible to eyeball that your range is going to be y can't be 2. And finally, we have a parabola again. This is a parabola that opens up and has a vertex at -3, -4. Shape like that. -3, -4. So, domain, well, it extends to the left forever and to the right forever, so there's no restriction on x. X can be any real number. And for the range, y bottoms out at -4. But it never tops out, it goes up forever. So for the range, we would get that y can be greater than or equal to -4. So there isn't a fixed procedure really for finding domains and ranges, except that you look for trouble. You look for division by 0, you look for square roots of negative numbers, and you use anything that you can think of about the graph to help you find the domain and range. You have to be on your toes. They're never terribly difficult, but they require some knowledge of graphing and a bit of an eye for detail. You'll get plenty of practice as the course goes on.